Hey, welcome back to my channel. Been a while since I've posted anything because I've been crook. Just to give you a bit of a health update on me, I've finished the chemotherapy. It's done. Come out of it with a clean bill of health, so I'm in remission, which, thank the Lord, that's going all right. It's kept me out of the marketplace because of people not willing to take a chance on me, but you know, so what? I'll just keep moving forward. Keep applying for jobs. Someone will give me a go somewhere. I'll just have to keep my faith that things are going to happen for me. Alright, so all that out of the road. Apologies for not posting for so long. As I said, I've been a bit crook with the chemotherapy, and the side effects of the chemotherapy are I've got a little bit of numbness in my hands and feet called peripheral neuropathy. And I'm just dealing with that, and it's supposed to go away at some point, and I hope to God it goes away sooner rather than later. I've got lovely breeze coming through the window, but my view has been blocked out by a bloke that's built 2 blocks away, 2 houses down. He's built a double story and blocked off what little was left of my view, so the view's gone. I can still see the eyesore of a building blocking the view for the Broadwater. I've got like a 2-inch slot between the front of his house and the edge of that building that I can just see the trees that mark out all the edge of the Broadwater. But other than that, my view's gone. They're still building that eyesore of a house two doors down, but you know, who cares, whatever. Okay, so the reason for this video, I'm going to take this opportunity to say, as usual, that I take no responsibility whatsoever for anything. If you're following along, you do so entirely at your own risk, and if you can't do that, then click this off and off you go. But what we're going to do is we're going to build a little wagon wheel insert for our spool of PLA. Excuse me. So as you can see, what the manufacturers do with these is they make them with a wagon wheel in them. And this little doogie here is the right gauge for my spindle, for my stand. And what's happened is I've got a new one. And it's got a really great big hole in the middle. And of course, that's not the right gauge for my spindle. So what have I done? Well, I've made an insert to go in that hole. I'm just going to leave that there for a minute. I've just finished 3D printing it. Here it is. And what I'm going to do with that is I'm going to make this. That just slides. Hopefully, I've made it the right size. I can force it into that part of the spindle. Now I measured that and it was a good solid fit, and with a bit of persuasion that'll go into that. That one's slightly smaller, I think, than this one. I hope. Oh, extremely much so. Look, I made it for this. Fits like a glove. There it is, in. It'll go through, no worries at all. Put the thing through the centre, put it back on the spindle. I've got it exactly the right size. Oh, not so much for this though. Well, it's got some. Well, the outer size was right, the inner size looks like it's got some roughies, so I've got to rough out the centre bit. So I've got to ring out the centre bit a bit. I can see on the edges of it, it's got problems. I've got a little knife here. I'm just going to go around the edge of that. And that's where it catches there. And where it catches, that knife will take care of that. I'm just going to ring that edge. Let's see if that'll go. It'll go, but it'll go too tight. I've made that centerpiece just a little bit, so we're going to make another one. It's going to be way too tight. Look, it's going to be a mile too tight. Oh, look, it works on this side. Doesn't work on that side. You know what? I don't care. It's in! Okay. Got to put it through the spindle now. Got to punch it through. It's got to punch right through. The outside one was perfect. The inside one's a bit tight. Oh well, shit happens. Alright, so as you can see, we had a bit of a failure with the inside one. It's just printed out a little bit too much in the word on the tight side. I'm going to make another one. I'm just going to widen out the inside hole and ring that out a bit more. Oh, that's never coming off now. Yep, that's in there. Oh, yeah, I should have thought about that, shouldn't I? That's not coming out. We'll fix that with the next one. Have to cut that off now. Oh well, such is life. I'm going to set that into the zone. You can just pull around. Just sitting it in the cradle. Doesn't really work very well on that thing anyway. But it'll continue to roll around and print out fine. So let's get into the printing. So what we need is a SCAD project. Once again, if you're following along, own risk. Righto, let's get into it. openSCAD. This is freeware, and openscad.org, thank you very much. And what we're going to do is we're going to open this one that I've prepared earlier called Insert, and that's what this is. This is an insert. Now, some of you may or may not have come to grips with the way I do programming, and what I like to do is I like to do object-oriented design. Now, we're not doing object-oriented programming. Let's get that out there. I'm not doing a full object-oriented program build for this particular project. But in the design, I've got some properties here. And you can see that I've got them commented so that people following along can see what I'm about. So my ID is my inner hole diameter, which I've currently got set at 22, and that's too small. We're going to widen that out by 2 millimeters. We're going to make that 24. My outer diameter was perfect, don't need to touch that. My real width is the width of the reel, which is how wide do I want to make this collar, right? So it's from there to there, right? The thickness of the reel. So that's what that's all about. That tells them, the system, how wide I want the system. How many spokes do I want? I want 6 spokes. And how thick do I want the spokes? And all the rest of the parts, 3 millimeters is perfect. Now, from that information, I can make some calculations, like my spoke length. And my spoke length, the length of the spokes, that's this bit from the center of the circle to the edge of the center to the edge, right? Goes from the center, because the last thing I do is I drill a hole through the whole middle of it, which is the bore, which is the spindle width, which is going to be the inner diameter of 24 millimeters. This is my build module, and all I'm doing is I'm adding the bore after I assemble all the bits. And that there is what builds the whole project. So this move spoke stuff doesn't get used anymore. I was playing with this and I created these variables and I don't need them. So they're going. So all I need is to work out how many spokes, the rotation angle of the spokes, and the length of them. And they're the two calculated properties that I need to do. So let's talk about the outer. Let's talk about that. What I've done is I've created two cylinders. And I'm just going to show you what outer looks like. So up here where I've got build all, I'm just going to comment that out. And I'm just going to build the outer. And what you'll see, it's a cylinder within a cylinder. I'm using this difference command to bore a hole through the outer cylinder with the inner cylinder. And I'm going to show you how that works by highlighting the inner cylinder for you. Well, let's just build that. So what I've got a slight little taper on it. See that? It's very, very slight. I've got a 1 millimeter taper over the distance of the collar. So it'll just slide in on the taper and grip. So that's here. I've got my height equals the real width. RW is our real width up here. I've got my diameter 1 as being the outer diameter, and my diameter 2 is the taper, which I'm taking 1 millimeter off it. I want it to be smooth, so I'm using a 100, which is why you can see these little lines. I don't want it to be too smooth. I want it to bite into the thing. So 100 is fine, and I want it centered. So for the inner one, I just need it to be the thickness. So my diameter is my outer diameter minus the thickness, which actually makes it too thin because it should be the thickness times 2. So there was an error in that. And it actually worked. Should actually be that wide. That's 3 millimeters wide. So I had an error in the software. How good's that? I just realised it as I was sitting here. Because the diameter means you want it 3 millimeters there and 3 millimeters there. So 1.5 millimeters actually worked. In our original, that 1.5 millimeter thickness actually did work. That ain't coming off there without a cutter. Have to cut it. I'm going to have to cut this out. Wish I hadn't done it. Oh well. So here's our outer, right? And that's exactly what it says it is. It's our outer. I'm going to take the highlighting off that inner cylinder so you can't see it anymore. So you can see what I've had to do with the inner one is I've had to move it beyond the reach of the outer cylinder and make sure it penetrates both ends of it. So I've added 4 millimeters to the real width, and I've dropped it down 1 millimeter at the bottom. So it actually goes like that, because at the moment the design is flipped 180 degrees. At the end, no, I'm not flipping it. I don't know why it's upside down, but it is. Okay, don't understand that. It's a little bit upside down, but I don't care. It's working. Alright, so let's build that, and now you can see I've got the hole through my outer ring. That's my outer ring done. So that was the first piece I built. Next thing, I had to work out the spokes. To do that, I had to build one spoke. So now I'm going to show you one spoke with my assembly. You'll note that I'm actually giving it the command above my modules. Okay? So assembly 1, we're going to see it with one spoke. Why am I getting that? Oh, okay. I built, because I hollowed out that cylinder, I put a new cylinder in. And once again, that thickness is going to be wrong. I only added one thick, which means I've got a 1.5 millimeter thickness around that inner one. You know what? The 1.5 millimeter thickness is actually working, but it's not good programming, so I'm going to change it. Now this is the beauty about changing your mind in a design that's modular, right? So I'm building this inner cylinder here. That's this cylinder, and it's got one spoke in it. I'm just going to comment the cylinder out really quick. So you can see the spoke is going from the center to the edge. Now I'm going to put that back. Does everyone understand that? That spoke, I don't want to trim it up to the cylinder because it's too hard to do the rotation. It's just too hard. You can rotate them around, but it's easier to do one bore through the whole job. Likewise, I could have bored through this cylinder. I could have chosen to bore through that and just add it as a thing, but then I would have had the spoke coming to the middle and I would have had to bore it out again. So I didn't want that. So now I need more spokes. I need 6 of them, right? So the way I did that was I've got a rotation angle here, and I'm rotating and building 360 degrees over the number of spokes. So if I've got 6 spokes, 6 sixes are 30, I'm rotating 60 degrees, and I'm building my spokes. So I'm using a for statement from 0 to the number of spokes minus 1. And I'm changing that rotation angle by the value of A and looping it around and building a new spoke for the number of spokes. So instead of spoke, I'm going to say spokes and rebuild that. And there they are. There's our 6 spokes in our for loop. Pretty cool. We're nearly done. Now all we need is to put our hole back through the center. So we just need our bore, and our bore is there. Now this cylinder, I could have put that in my outer. So I can take it out of here where it makes no sense. Control V. And put it in there after the difference. And you can see that didn't change at all. You just comment that out so you can see what's going on without that cylinder in there. Oh, Control Z. Oops, redo. I'm hitting the wrong buttons. I'm commenting out the wrong cylinder. Sorry guys. Here we go. So there's the spokes and the outer. So this outer here really has to have that cylinder in. It belongs with this. That's all of the outer built. Now all I've got to do is put the ball back in. Get rid of this. Run it, and there's our bore. And it's got a bigger bore in it this time because we changed it. Now remember I said the 1.5 worked? I can drop this from 3 to 2. Watch what happens. Bang. Way, look at that. She just changed. If I want to make it 8, I can make it 8. Watch what happens if I make it 8. Woo! That really gets going, doesn't it? So 8 doesn't really work. So I can put an if statement in there and say if thick is greater than 8, make it 7. At 7 I'll get a little bit of a gap somewhere. Nope. What about 5? There we go. At 5 I get a little bit of a gap. Maybe at 6 I'll get a little bit of a gap. So I could put an if statement in there. If thick greater than 6, thick equals 5. Or, you know, if thick greater than 5, thick equals 5. I can put an if statement in here. So I can do some... I'm going to do it. I'm going to do a sanity check. And I'm going to run from the cheat sheet. So I'm going to go help in my cheat sheet. I need the if statement. So I'm just going to open this up. Got to make sure you've got an internet connection. Slow. Don't know why the internet's so slow. Oh, maybe it's the computer that's slow. Who knows? I'm making hard work of this, let me tell you. Here we go. And now if statement is here. I'm just going to grab the syntax for the statement and copy it in. So now we've got a little bit of sanity checking in our code, which is always good to have. So if thick Control V is greater than 5, then we want Control C, and close our bracket. So now let's make thick 7, and that won't change. Well, yes it will. Okay, what did I screw up? Go back to the syntax. Oh, else thick. Oh, okay, it's not a complex command. So we don't need this. I mucked up the syntax, I grabbed the wrong one. So just a quick sanity check. Thick equals 7. Boof. Oh, come on. Line 17, syntax error. I give up. Okay, I'm having some problems with this syntax. Is it this simple? It's ignoring this. It doesn't like it here. Should work. It doesn't like this statement. This is the fun of doing things live. I don't know why I can't get this if statement to work. Maybe it needs it. I don't know. Maybe I just comment the whole bloody lot out. I'm going to call it 2. Happy with that, Jan. I don't know what's wrong with this. I'll figure it out off camera and I'll fix it up some other time. There's a single there. Oh, I don't know what I've done wrong there. Doesn't like it. It's ignoring it. Works for that. If I make that a 7, it ignores it. Okay, enough mucking around. There'll be a bit of editing going on, I think. Who knows? I'm going to keep it at 2. 2 works. So I'm just going to add a comment up here thick must be greater than 0 and less than 5. I'm just going to add that comment. I want to get that sanity check to work, and I'll do that off camera. Save it. Righto, so that's our design. We're done. There's our wagon wheel. You can see my spokes aren't quite all the way to the end of the design. That's by design. I don't want them all the way to the end. Quite happy with them not to be all the way to the end because I save a bit of printing material. So let's go ahead and start this off. So what we want to do now that we're happy with this, which I am, I'm going to make this. So this compiles the design. We're sort of moving forwards. Now what I'm going to do is I'm going to swap cameras up. I don't know if this one's even got any charge in it, but I'm going to have a crack. Well, according to this, it's full. Righto, so I'm going to pop this up on the 3D printer somehow, so you can see it. You can see I'm playing with the tripod. I've had this for a long time now. I looked after it a bit. You know, it's fallen over a couple of times. You're going to get the view of things. Maybe the view out the window, who knows. And there's the tripod set up. Hopefully I'll capture the 3D printer. Now what I'm going to try to do here is zoom it in on the printing head. The lights there is not very good. Oh, there goes the battery. So it's nearly out of battery. Righto, there's the light. It didn't like the battery charge, so we're going to have to charge up the other battery, which if I can find the bloody thing, and we'll get it going. But let's get this up and running. So we want to create the STL file, and I've called it insert. And I'm going to load up the Repetia software. I didn't mean to close the Repetia software down, I just did. Oh, I'm really not thinking straight, am I? I don't know how many times I do this, talk to a computer that's not recording me. I just started another one, and can you believe it? I've been talking for 5 minutes to a computer that's not even recording me. Righto, so what we've done is we've broken this up into 2 halves because I've got over 2 hours of footage, and a lot of it is me sort of diving deeper into why I did this or why I did that. Now some of you like that, and a lot of you just want me to get on with it, and in this case I think this is just one of those cases where I can get on with it. So we're going to chop it into 2 halves, about, kind of watchable lengths. And hopefully you'll tune in for part 2 where I actually do the print and we use the Repetio Host software. Now, this is going to be the end of this part. I want to talk very quickly about object-oriented design, which is what we did here. Now, what I didn't do is I didn't show you what I started with, which was my conceptualization, and this was it. This is what I had in mind, and I actually write it down. I actually draw it on a scrap bit of paper, and you can see here I've got like an outer point, an inner point, and some spokes, and that was like a wagon wheel, and that was my conceptualization of this thing. And you can see I've got yokes which are inner and outer. I've got a thickness and I've got spokes, and that was as much as I really could think of in terms of properties for this particular thing. Now what I want to do is I want to move across to the screen recorder. I'm just going to put this up here, and we're going to move across to the screen recorder at this point. Just give me a second. You can see I'm editing with the photo editor, you know, really sophisticated software. But I do have this screen recorder called Ice Cream Screen Recorder, and I just want to show you real quick in SCAD what I talk about when I talk about object-oriented design. And for whatever reason that didn't start. I'll open this up as we go. So I'm just opening the insert back up, and I want to talk through the properties of object-oriented design, which is how I really don't want it in full screen. Why is that? Right, now we're golden. I'm just going to get this across here somewhere. Close that down. Right. So I want to talk to you about what this led me to when I started talking about properties. Right? So here you can see inner diameter. Well, that's this bit in here, this inner diameter. We have an outer diameter, and these were measured with a set of vernier calipers, right? The real width, the thickness of the reel, right? So obviously this is 2D. We have a thickness. The spoke count, we want 6 spokes. So I've got spokes, right? So we need a thickness, and I just said 2, you know, the thickness of all these parts. So the thickness of this yoke, the thickness of that, the thickness of the spokes. These become interesting because once you've got some basic properties, you can then calculate some properties. So, for example, the spoke length, the rotation angle, right, which is 360 degrees over the number of spokes. The limit of thickness for the wagon, you know, so the outer diameter over 10 has to be your limit, right? A little sanity checking, you know, right? Just an echo designer, I think it must be less than TH, which is a calculated value, which I've just put it in as in the end, I settled for that as my sanity check. Right, modular things. We've got build all, which builds it. And you can see here what I'm doing is the last thing I'm doing is I'm adding the bore, right? So this is the assembly. I'm putting the outer and the spokes together. I'm putting the bore together. I'm putting an outer together, right? Outer, inner, right? You see what's going on? I've got a spoke, right? You know, that's it. I've got an outer, an inner, a spoke, and a bore. So that's what I've built. I've built an outer, an inner, a spoke, which I've then said I need that to be the number of spokes I need. So I've got an individual spoke, which I've turned into spokes, which builds the spokes around the perimeter. So there it is. based on this drawing, a few properties, a few, you know, you're done. You've got an object-oriented design. Let me just, yeah. Right, so we can lose the screen recorder. That's what I'm talking about when I talk about start with something in writing. Give yourself a plan. Write to your plan. Now, this isn't a flow chart, this thing. It's just a conceptualization around which I had a few simple components. So I didn't build a flow chart, and I didn't build the other bits and pieces which make it a good programming technique. It's still a good programming technique. You saw I had comments. Right, so people following along could see what I was on about, what I was trying to achieve, and I gave my my modules meaningful names: assembly 1, assembly 2, assembly, so that you keep adding to the assembly, right? The build it, build all, you know, builds the whole thing, and then it gets back down into components, you know, inner, outer, spokes to, you know, to propagate your spokes around the perimeter. I think it makes sense to me, and if it makes sense to me, I could come back to this bit of code and recycle it, and recycle it, and recycle it, and keep going. And that's what you want to achieve. You want to be able to recycle code that you've written. So I could take this whole module. If I need a spoke for something, I can just pick up that bit that says spoke, and pick up the properties pertaining to the spoke, and then put it into another piece of code and recycle that. And I haven't reinvented my wheel. I haven't wasted time. And it's important that you have this library of things that you've done where you've given it a meaningful name. And eventually what you'll do is build up code libraries. And when you've got a code library, you can actually call it into your project. So you'll have this code library of common parts that you've built over time. And it's the same with any bit of software you use. It doesn't matter whether it's CAD software. If you build a ball bearing, you should be able to call that ball bearing and then change the properties of it somewhere in your code. And you'll get exactly what you want in another bit of code, you know? This is what I'm saying. This is simple programming 101. And that is to make things modular so that it's easy to recycle, so that it's easy to read and easy for other people to read, right? There's nothing worse than getting involved in a project where someone's come along and written spaghetti code with magic numbers in it, and you've got to sit there and there's no commenting, and you've got to think, where the hell has this gone wrong? Why doesn't this work? And you can see why it doesn't work. It's because it's terrible programming. It might work 2, 3, 4 times out, but then some variable is introduced into the environment which wasn't accounted for in the code, and you've suddenly got to insert that in this spaghetti, and you're like, oh God, you know, save me. You got to do it in 5 minutes, and it's taken you 2 hours just to understand what the guy's done, because it's not comment. So you're adding comments, you think it's what it's doing, you think, and then you're trying to make sense of the code because it's just one script, and it's just not organized, and it's not nice. Modular programming works, and it works whether you're in C, whether you're in Assembler, whether you're in AutoCAD, whether you're in a spreadsheet. Doesn't matter where you are. If you're writing spreadsheets, I know people are really good with Excel, and they can pretty much make it do anything, and it will let you do anything pretty much. The trouble is that they're really bad programmers, and they just get spreadsheet, nested. Sometimes they've got nesting 15 layers of nesting in a single cell. And you're like, what the hell is he trying to do with this? Because he's gone 15 layers deep. He could put those cells out one by one and join them together, you know. And then each cell has got each component, and then you know immediately what he's trying to do because, oh, that one's not working. Great, bang, fix it. Ah, look at that, works. Otherwise, you've got to dig through the nest and, what's that trying to do? What's this trying to do? What's that trying to do? Ah, doesn't work. You want to componentize your designs. You want to figure out what the properties are, what attributes each property has, and away you go. These are all subcomponents. These are all attributes. Thickness is basically the only attribute I had there, other than I had a width, the real width. That's the one thing that was missing from that. But it came about, and you could see it very clearly, and it became something that was easy to do. I think you've got to just maintain a focus. You need something that stops feature creep. You need something that stops, adding bits and pieces that are unnecessary to the job, which is feature creep. You need something to keep you focused on your goal. And it's the same in life. You've got to have a plan. You've got to have it written. You've got to have some idea of where you're going to go next. And as you get things, you cross them off. Bang, yep, done that, done that, done that. Oh, didn't do that really well. Redo it. Yeah, okay, done that. Next. And you keep moving forward. And let me encourage you to keep moving forward towards your goals. I want you to keep swinging. I want you to make good decisions and do good things. Look after your community. Look after the people around you, the people that matter. Even if they don't matter, they matter. They really do. We can't afford to be at each other's throats. Look after your planet. Recycle. Do the right thing. Make good decisions. Do good things. Keep swinging at your goals. And I will see you for part 2 of this video.